Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It's my absolute pleasure, delight, and honor that my dear friend, Professor Jyotishman Dasgupta from Tata Institute of Fundamental Research, Mumbai, Chemical Sciences professor, is joining us on this particular episode. Jyotishman is an outstanding spectroscopist, chemist, and also works on various different problems related to energy, including solar cells from a chemistry viewpoint, and has contributed deeply in understanding how light interacts with matter, which actually has taken him into various different forays, which also includes Raman scattering and so many other beautiful things in science. To succinctly put Jyotishman's work and also his presence, he is a scientist who is not only passionate but also compassionate, which actually really sums up everything what Jyotishman does. I have learned a lot interacting with him over the years, both as a friend and also as a fellow scientist. And it's my absolute pleasure to welcome Jyotishman on Pratidwani.
Thank you. Thank you, Pawan. This is an absolute honor that I have been invited here. I always felt that I need to gain a little bit white hair, more white hair, although there's quite a bit, before I can enter this. But thank you for calling me. Probably any time is a good time having a conversation with you, but I would like to thank you for putting this effort to put Pratidhwani across the Indian scientific community. And hopefully this will serve as a place where, scientists, young scientists, especially growing up in Indian academia, PhD students, postdocs can go to and see, what inherently drives a scientist on a personal level. And it also kind of inspire people to sort of, because many of the stories that we speak in such forum are very deeply personal, and also we share stories of failures. So this is should inspire people who are seeing failures quite a bit and still want to pursue science. And I think that's very important. And I think you are doing a fantastic job of sharing these stories. So thank you for doing that, Pawan. And hopefully this will inspire people.
My pleasure, Jyotishman. It's an absolute pleasure to talk to a lot of people like you, and everybody whom I generally talk to actually readily agree like what you did. This particular episode was due for a very long duration. I have had so many people also, writing to me telling that why not Jyotishman, and something which including, for example, my own former students like Sunny Tiwari and other people were asking that Jyotishman should be on, and it's my pleasure. So,
wonderful student, by the way, just to
yeah,
mention,
yeah,
one
yeah,
of you.
yeah,
And you have remarkable students over the years. I've had Rohit interact with me. Sunny, of course, but Pawan, you have been lucky with fantastic students, and Iser Pune gets amazing talent. So you're in a great place.
Yeah. In fact, that's been one of the pleasures of interacting with a lot of students over the years, so many of them, and they have become kind of a springboard for our own knowledge, to be very frank. So, Jyotishman, we will get started with the conversation related to your origins. Give us an overview of where you were born and brought up, and your background, and how it motivated you to do science. Yeah.
Yeah. So, Pawan, I think one of the sort of things that I would like to share is I come from a very small town called Bhilai. That's where I was born, and my parents pretty much hail from a very culturally rich family, I would say. From my parents' side, my father was born to a family of 11 brothers and sisters, and all of them grew up in Kolkata. And this was pre-independence, and all the kids born to that family had huge amount of influence from the grandfather, my grandfather, who was a government employee in public welfare department in Assam, but had moved to Kolkata later on. But he passed away pretty early in his age. And everybody was sort of brought up by the grandmother, the central figure, who by education wasn't having a lot of big degrees, but she was very much educated in terms of putting the family together of 11 and making sure all the sisters pursue education beyond the bachelor's degree. And that at that time, with six sisters and five brothers, this is a different mindset. But she wanted each of them to have an advanced degree in some form. In fact, one of the sisters turned out to be a mathematics professor in Kolkata University. So this is fantastic. And all the other brothers individually turned out to be one of them was the main editor, the chief editor of Hindustan Standard, a famous newspaper. And later it went into the Times Group, Times of India Group. But so my father was in a pretty culturally rich family, hardened by the loss of the main earning member, but brought together by the senior brothers who had taken the responsibility of earning the bread and also providing. So he has been for me an incredibly influential person in terms of bringing cultural information from the family, both education wise, degree wise, of course, that's what we learn from textbooks, but also from a broad mindset of, I would say, telling me who we really are the roots, at the roots, how rich the culture in Bengal has been in literature, arts, music, telling me about classical music, from the very early age. And me and my brother have been heavily influenced. So this is where my origins were. My mother's side has been rich as well. My mother's side's grandfather was the chief medical officer for Nepal, king of Nepal. So Kathmandu is also a place where I can go and find my older generation of relatives from the mother's side. So, and my mother's father was a graduate in electrical engineering from BHU. So all of them had a heavy influence on my upbringing. That education is not about just clearing up textbooks, but also being nice as a human being, and being kind to people. And I think they have had a tremendous influence. So those are my basic growing up time, which I wanted to mention and thank my parents for doing that, and for my brother and me. And of course, my brother turned out to be a professor in IIT Kharagpur. He is now currently a professor. He is 9 years older to me, Professor Anirban Dasgupta. He is a faculty in mechanical engineering and with specialization in robotics. But he has been also a big influence for me. When he got into IIT system, I knew I had to go into IIT system because my brother did it, and I was lucky to follow his path. And I'm not as good as him, but I've tried my best to match his talents in terms of his understanding of the physical world, really from an education point of view, as well as of course his own talents apart from that. So I'm heavily influenced by these three people.
Fabulous, fabulous. In fact, this also segues us to really ask uh, how JD became. JD is the short form of Jyotishman Dasgupta. That's what we call Jyotishman. And so I would continue to call JD because that's our favorite kind of acronym for Jyotishman. So, JD, please tell us a little bit about your early influences in science, especially your schooling and also your basic education, your primary and also school, probably even into your college. How was it, and what were your main influences?
Yeah, Pawan, I grew up in Bhilai, as I said, and there were steel. My father went into a steel plant. He worked there. So this was a steel township around which my schooling happened. All the young, from junior school to middle and to high school, we were lucky to have good teachers. But I cannot distinguish or pinpoint a section of time where I thought I will become a scientist, to be very honest. And I sort of was good in history, in social sciences. I was okay in mathematics. I was also okay in science. I was not sure if I was good in any one discipline. This is something that has sort of bothered me from my early childhood, that I didn't have a path which is well defined, as I see my other scientist friends, including you. This sort of clear mindset that I will become a scientist. I was not sure. What I can say is I was okay in pretty much all the subjects that I was doing. But there was an influence externally, not from directly from the teachers in school. But as I said, I come from a very academically rich family and culturally rich. So my father's brother, apart from one of them being a journalist and being the chief journalist in Hindustan Standard, the second in line, second in row, uh, Dr. Shobita Dasgupta was a very famous gynecologist in Jamshedpur. In fact, he was so well reputed. He actually was the president of the World Gynecologist and Obstetrics Society, which is based in UK, in Edinburgh. And he was very close to our family, the extended family. And one of the influential points I remember, maybe science would have been one way to think about it, was he talked to me in class 12th. And this is when I went there in Jamshedpur after the death of my, his wife at that time. And we had a conversation in which he pretty much told me that, Jyotishman, you can do, he used to call me Obhik, that's the colloquial name, the pet name. He told me that I do look at a lot of science that is coming up these days as a doctor, and he was heavily influenced by small molecule neuronal activation. And he's a gynecologist, he doesn't work on the brain, but he was sort of getting influenced by how chemicals can trigger events in the brain. And one of the important things that he mentioned to me at that time was a molecule called NO. And you won't believe this is, I'm in class 12, I know chemistry a bit, but he told me, if you really are interested in any directions of science, do think about looking at the influence of nitric oxide, because it is a very important chemical. It has huge influence in the neuronal circuit. And this conversation happened, Pawan, in 1994 or 1995, close to 1995. At that time, NO was considered an important molecule for the next 1 year. It was declared as one of the important target molecules to think about how it influences brain. So this is the kind of quality of discussion I had with one of my relatives. Just imagine. And I had no idea. It was interesting and an information item, but it left indelible mark in my mind that there are interesting things that chemists can do in principle. And so when I got a chance to study chemistry in IIT Kharagpur, which was sort of based on the rankings, right? IIT JEE has ranking system going on from 1 to I don't know how many nowadays they give, 25,000 or something, or 50,000, I don't know. At that time it was 2,500, and I was at the pretty much at the bottom part of it. It was somewhere in 2,400s ballpark. And my brother told me, look, engineering disciplines are out of question at this point. If there is a possibility, if you're interested in science, then IIT Kharagpur has a chemistry program which you might be interested in, and you can get into it. And I think I was okay with it. I said, since you have gone to IIT Kharagpur for your mechanical engineering degree, I want to go to IIT Kharagpur because my brother has gone, so I will go. So, as if from young age, everything that your brother does, you want a piece of it, right? So it was just a feeling that. But when that happened, Pawan, I think I got a chance to think about things from a perspective. And I recognized chemistry is not that difficult for me. It was not the exciting subject that I immediately would relate to, but after first year, I recognized I can do this. So, so gradually that became a motivation to look for research questions, and that had driven me to graduate school, which eventually I went into. Um, uh, Luckily to Princeton in chemistry. But that I was not sure whether I can say there was a scientific influence from the teachers, but I can definitely say, Pawan, there was an influence from my relative,
Okay.
and
That's very interesting.
a huge influence. I think, and I could see him write papers on different aspects of medicine and biology. So something subtly went in that this is a profile that could be in future. Maybe I never thought about it, but this could be a job profile. That
Wonderful, wonderful. So, JD, if you look at this kind of, influences, most of the time, these influences actually are also serendipitous, as you mentioned. It need not be always coming only through the formal education channel. And you also mentioned that influence of having an intellectual kind of family really helps. Uh, in a way, it's also a privilege because in India, really people actually don't have that opportunity to have such kind of nice people around, especially who are deeply invested in knowledge, who will encourage people in knowledge. But if somebody wants to actually develop such kind of, some kind of ilking towards to science or some intellectual pursuit, which I still believe is a good path to lead, even in the day and age where things actually have become so pompous and also the quite of sometimes exaggerated. So, what is your thought process, JD? Because you have also interacted, you have also been an outstanding scientist, but also you have kind of also interacted not only in the sphere of science, but also beyond that. And given this exposure you have, what is your thought process? Because if some student, let's say, asks us, uh, how should I make up for those lost opportunities or those here un kind of exposed kind of opportunities which let's say somebody would have had. How should we think about kind of helping such a student? Just a kind of an open-ended question, but I think it would be nice to just hear your thoughts on that.
no, this is a fantastic question, a very difficult question. You can't create serendipitous opportunities. You have to be lucky to be in the right place. But what you can do is, if you had that experience, share that experience. And I, my own experiences, which have shaped my thought process, has also led to me to believe that we lack currently abilities of scholars to pay attention to others' problems. And I think, as you correctly mentioned, Pavan, and I think we both know that we are living in an age where scholarship goes down, but publicity takes over. And That's because of social media, because of many things that we can do on an individual level. Earlier, the publicity was a right that you can associate with a very elite class of people called journalists. At that time, elite class. I still think they are in some sense more privileged than others. But journalism has lost its impact simply because individual has come to the fore. Anybody can actually be a journalist. Anybody can take a social media platform and disseminate whatever information the person has as right information for the community. So, in this regard, I think a platform like yours, I think, does much more than what you really believe in. Because I think the power of this kind of a platform where you sort of talk to people about their experiences is in going to be sort of highly influential. And I think um, one thing I would like to mention from what I learned from those experiences, and I can come back to the original question, is um, I think you have to be passionate in what you do, whatever you do. And I did see that in all my uncles that I talked about. One that I did not talk about, Professor Padmanabha Dasgupta, who, as a amazing teacher of repute in Kalyani University in physics department, we lost him last year. But there were so many teachers in TIFR in India who have been taught by Padmanabha, as he used to be called, is that you can be a scholar and you can be a humble person. Somehow, we don't see that enough in the community now that we live in. He used to always come with a dhoti and kurta to teach his classes, and used to speak polished, sophisticated English, used board work, again, something that is missing now in many places because PowerPoint and other kinds of writing activities on digital boards are feasible. But all of that sort of was on display when we young kids would used to meet him. And they kind of told us that in real scholarship lies is the honesty to help people. I think that's where real scholarship lies. I don't think it is about me first. It's about what you can give to the community. And the other thing is time. Apart from just the knowledge, the time and listening to people. So I think these two things I would suggest that are something that has been missing in the entire culture that is being propagated now. Helping people and being humble about it, and giving time. And this is something that I guess it's a losing brand at this point. I do not know if you can create opportunities for kids who have missed out on these kinds of interactions with ex, you know, past years of generation, golden generation. But what I can say is, um, uh, at this point, you, me, and our colleagues have opportunities to set up national level platforms. FCS is one of them, where you can sort of mix with the younger community and sort of have that interaction feasible for students, where they can sort of get in touch with really a person who demonstrates what real scholarship is. I think it's not just about doing great science, without any question. Doing great science is absolutely the priority, but it's also how you talk about that science and how you educate people with that science and you give time. I think those are the other three aspects which I think is important.
Fabulous, fabulous. In fact, it's such a critical aspect. As you told, it's also a complex kind of a concept to really unpack and see how one can contribute in that way. I would probably also add one more thing is to read broadly, especially students of science. Of course, they would always be educated in sciences, which is critically important. Without that, without very strong foundations, you would not be able to do good research. But also to have this kind of intellectual life, which is kind of mainly focusing on the depth of the subject. There's also a breadth within the society which has to be developed. And there's a lot of scope now to really go and explore a lot of literature, etc. And reading is one thing I would surely add to this particular list.
Absolutely. I
And
completely agree. And I think you have done a fabulous job. I keep seeing your posts on social media. You have a very directed focus. You bring concepts that have been talked about by legends of physics to the common public. And I think that is something which is, I won't say, Pawan, that anything that you do is a thankless job. I think you will be thanked in generations to come. Simply because people who go through your post will have a good understanding of where the concept originated and what are the limits of the concept. I think people confuse many of the problems in current literature has been a mixing up of words, phrases, terms without deeply thinking about whether it should be used in this in a paper or so. Well, just to give you an example. So I think you do bring out the fundamental concepts, and I think that is one way to really propagate science, and you're doing terrific job at it.
yeah, I should also thank the kind of ecosystem I am in, because it's part of my teaching duty, kind of duty what I actually have, and that's something which is very beneficial to always. Anyway, now
Yeah.
moving along. Uh, so JD, tell us your foray into science, which is now international. You finish your IIT Kharagpur degree in chemistry, and this includes a master's thesis also, if I'm correct.
Yes.
Yeah, yeah. So probably that would have also given you the initial exposure to some research. Tell us the transition from MSc, IIT Kharagpur, all the way to one of the meccas, which is very fascinating, Princeton. So, yeah.
Okay.
So
Yeah. So coming back to your question about IIT Kharagpur and the entire program. I think I was, of course, as I mentioned, I was, uh, I was at the bottom half of the 2,500 students picked up that year in 1995. So, but my brother kind of told me that, look, science is available, and in IIT Kharagpur, chemistry is available. So maybe that could be a good spot for you as you have some interest in science. Maybe you don't know whether it's chemistry or not, but you have an interest. And if you don't, then in the first year you do well, you might be able to change your topic. You can switch to engineering, for example. I said, okay, well, I just knew that I had to go where my brother went. And it was a 5-year program, Pawan, and this program actually aims, and I'm an alumni now, so I would like to say that it it aims at a broad training of students in chemistry. You can choose specialization in the final year for a project, whether you want to work in physical chemistry, organic chemistry, or inorganic chemistry. But over the 5 years, at least, what we received was a broad training. And that helps, Pawan. In all honesty, with the amounts of mathematical courses that I had, the physics courses that I had, it all seeped in. Whether or not I use it directly, indirectly, I do not know. But, that broad training in the first year, where I learned engineering physics, and I looked at a famous undergraduate textbook by Shames which looks at, all sorts of problems in physics where you have these structures, right? Mechanical structures, and you must have gone through similar kind of training. Then we had optics, linear optics, and in the first year, second semester, we had quantum mechanics in the formulation. So it was a very diverse, from engineering courses to physics courses to chemistry. We had a diversity of coursework, and I think that really, I didn't see the benefit of it at that time because it was too much of work. I had an electrical engineering lab, too much of work, right? But today I understand that sort of that broad training, even in my second year of chemistry, was very good. And I didn't become just a organic chemist. I didn't just become an inorganic chemist or a physical chemist. Uh, that I think is the root of my excitement in all of chemistry, also in physics. So, but yes, so that program, in my third or fourth year, I had a senior student in the residence hall of residence that I was in, who suggested to me. His name is Indrajit Mitra. He did a double PhD in physics and economics from Princeton and MIT later on. But he was an absolutely driven guy in physics. Okay. And he told me, Jyotishman, you just have to get up your grades. You need to get above 90% to apply for positions abroad. And since I see that you have this interest in science and research, you should definitely look for positions abroad. And so I think IIT Kharagpur did two things to me: give a broad education to me, and I'm very proud of. It is the oldest IIT, and it had a much larger set of departments. Still, it has, and a fantastic bunch of teachers. I really think I had fantastic teachers to learn from. Shabani Tarabdar is a statistical chemist, a statistical physics person. She was very young faculty. She joined, and there was Shagata Dasgupta, who does a lot of biophysics. There's Chottaraj, Professor Chottaraj did a lot of quantum chemistry research. He looked at these hard acids, hard-based concepts developed theoretically. Then, I had Sani Grahi, one of the famous quantum chemistry person who taught us. I still use his book for teaching sometimes in quantum chemistry. So I had a good set of teachers who really broadened my understanding, and they were good scholars. They were good researchers, and I think IIT Kharagpur still has fantastic researchers. So these are people who really pushed me into a direction. And then, of course, my peer group and my seniors in the hostel pushed me towards more deeper education and a PhD and going abroad. I don't think I knew that I should go abroad. This is another question that students face: should we go abroad or should we stay in the country? I think it was just at that time, Kharagpur had all these students going abroad, applying abroad for PhD positions. So it almost felt like a Mumbai local. In a platform in Mumbai in rush hour, you feel that you don't know which train to pick, but people push you in. So I felt the same way, as my peer group and my seniors pushed me in towards direction of a graduate school and a PhD program. Whether or not I would have loved to do it, my PhD in India, I did not make that assumption or make the choice. I applied for TIFR, this VSRP program. I don't, Pavan, you know about this, right?
Yes, yes, yeah,
Yes,
yeah, yeah,
yes.
yeah.
So the VSRP program was a place where I came, and it was apparent that I love to do research. This is where I learned for the first time that I love to do research. Um, and I did not get a spot for a PhD in TIFR. So I did an interview. So the VSRP program used to be a seeding ground where they used to interview all the VSRPs for a position in chemical sciences, in physics or in biology. So in my batch of VSRP students, one student got the offer. I wasn't the one. But I understood, and I met Shudipto there. I met Shudipto Maiti, and I understood.
Nice. Mm.
I really understood that, I need to do research because there's some unbelievable optics going on in the country, and questions that are in biophysics, something that I would remember from my uncle telling me, right, that neuronal activity is important to monitor. And Shudipta Moiti was doing those multi-photon experiments, and this was in 99. He was building this lab and his students were, so I absolutely loved that environment, and TIFR provided that catalytic power to push me into graduate school. So I'm lucky that IIT Kharagpur students got a chance in VSRP. I don't know if you know Rahul from ISC Bangalore. Rahul Roy.
Rahul Roy.
Rahul Roy. He was my junior. So once I became a VSRP, he came to me. And he said, Jyotishman, he didn't know me. He was in engineering program. He said, I heard you went to TIFR for a VSRP program. And Rahul is the first person I excited. I communicated the excitement, and I told there's this guy Shudipto Maiti. You have to go there. And Rahul joined Shudipto for a VSRP program, and that's how his microscopy path came into fruition. So, you know, Kharagpur was a fantastic place that I got a chance, maybe because of the brand value of Kharagpur. I really think it's not because of my talent. I think it was because of the brand value. And I got a chance to see really fantastic research in TIFR. And that told me I am going to do PhD. And wherever I get, I applied to all the universities in the US, and my brother gave the money, funded me. He became a faculty. He was a young faculty in 1999 in IIT Kharagpur in mechanical engineering. So he gave me money. Of course, my parents also gave me money, but I spent all that money that my parents gave me. So my brother funded me for this to apply, and I applied to 10 places, and I got through Princeton and a couple of other places, and yeah, and that set me free, I think.
Fabulous, fabulous. You painted the picture so beautifully. I have to, for the listeners and viewers' sake, I should mention that Professor Sudipta Maiti, who has been a friend, guide, a mentor to so many of us, an outstanding scientist who actually has a very broad perspective from optics to biophysics to chemical sciences. So many of them actually have benefited thanks to his kind of world famous fluorescence correlation spectroscopy meeting, which is not just only about fluorescence correlation spectroscopy, but it is a very, very famous hands-on meeting, which actually kind of reorients how you should do experimental science with an emphasis of using your hands and brains. This is something I keep telling that. And Jyotishman has been at the forefront of also leading some of the very interesting topics in that particular program, which happens every December of every year across India, where so many of us have benefited. So many of our own students and many of the students across India have vastly benefited from that program. So if somebody is listening to this or watching this, do actually think about and apply for that program. It's a wonderful program where you get hands-on experience and also a lot of interaction time with a lot of people like Jyotishman, Sudipta Maiti, Anindya Datta, who also has been on Pratidwani, and that's a fabulous program. So, Jyotishman, give us an insight into the questions what you are asking during your
PhD.
PhD days, and also followed by your postdoctoral days, which was again in one of the greatest departments of chemistry in the world, which is in the University of California, Berkeley. So,
Yeah.
up to you. Yeah.
No, so thank you, Pawan, for mentioning Shudipto and his fantastic contribution. So a little contribution he also had in pushing me towards graduate school. And I always wondered, am I going to be a good enough student to actually join a Shudipto Maiti group? So this has always been my question. And if I had gotten into TIFR that time, they didn't take me. I would have definitely loved to work with him. So I just want to say that if Shudipto listens to this video ever. No, so at that time in late in early late 1990s, early 2000s, that's where the time I graduated. I had a tremendous interest in NMR spectroscopy. That's what project I worked in Professor Sonawat's group in TIFR at that time. And everything that I did in TIFR, somehow my mind told me I need to translate that in PhD. So because I was so motivated, seeing multidimensional NMR spectra, right? This is the time when multidimensional spectroscopy has its roots in NMR. Okay, from early 70s when Jenner proposed the idea that you can do a spectroscopy experiment in 2 dimensions, right? Rather than a single dimension, where cross peaks could have more information than your standard diagonal peaks of a 1D spectra. It was translated to optical spectroscopy. Of course, we know, Pawan, we have seen exponents of that in India doing multidimensional optical spectroscopy, but NMR was the first. And the reason NMR was the first was the lifetimes, the coherence lifetimes in NMR is in the order of microseconds to milliseconds, sometimes to seconds. So these are long lived and you can detect these. So I got interested by looking at the theory of NMR in magnetic resonance spectroscopy. And that is how I applied to Princeton, who had Warren at that time. Warren, just for the reader's introduction, Warren was a very established magnetic resonance and optical spectroscopy person who sort of initiated the idea of using magnetic resonance for quantum computation. So he was in Princeton, and there was a famous student of him from India, Devbrata Goswami, who did his PhD with Warren. And so I had sort of a feeling that I am going to go towards multidimensional NMR and these exciting applications in quantum computing and things like that. And in a chemistry department, by the way, in a chemistry department. So, but turned out that I got the email from Professor Charles Dismukes, my eventual PhD mentor, who told me that, dear Jyotishman, your application seems to be one of the top applications in the chemistry department this year, and you have, sort of inquired about magnetic resonance. I am tremendously interested in your application. I do a lot of pulse EPR spectroscopy, and would that interest you? And when a person doesn't know what hit you, right? Some professor from Princeton is writing to you on a personal email. You just don't know what to do. You said, yes, of course, I'm interested, right? And I had no idea what I was going to get into. But I just said, I'm excited. Yes, Professor Dismukes, I will be interested in EPR spectroscopy as well. I just don't know what it entails, but it would be great if I learn it with you. So he said, great. And then he told me in January, before the letter came, he told me, Jyotishman, I just defended your case and you are through. So I was super excited. Within a week, there was a letter in my hostel office. I got it in my hostel, and it was unbelievable. Okay, it was unbelievable. So,
Fabulous.
yeah. So, and then I decided I will go to Princeton. I would like to work with Chuck. Eventually, I called him Chuck, Charles Dismukes as Chuck. And it turned out to be one of my really gratifying experiences in my life. It was not easy, as with any PhD. The moment I entered, I saw the Chuck's group was small, driven by senior scientific staff, like senior postdocs, not many graduate students. And I recognized not many graduate students could survive. And there was this one senior graduate student who was working on not spectroscopy, he was making inorganic complexes. Dr. Tom Carroll. So he was there as a guide, but only one PhD student, and the group meetings would be 5 people. So I was like, what am I going to do here? And for 3 years, I was struggling to what am I going to do. Ultimately, I knew that the group has strong interest in photosynthesis and natural photosynthesis. And Chuck had been a pioneer in sort of looking at water oxidation, which is a very important problem now. If you think of energy conversion paradigms, people in the catalysis community want to do water oxidation to generate dioxygen as a way to sort of have sustainable science, sustainable energy conversion ideas. So Chuck looked at natural photosynthesis that does water oxidation, and he was the first in early 1991 to come up with this paper, the famous paper. Sorry, it was 1981, where he came up with this famous paper during his tenure track, where he identified an EPR signature, electron paramagnetic resonance signature of the cluster, the natural cluster that does water oxidation. It's a manganese cluster. At that time, nobody knew it's a tetramanganese cluster. And Chuck's EPR spectra, which was rich in hyperfine couplings, okay, told the world that it's a magnetically coupled tetramanganese cluster for the first time. And this was a famous paper in PNAS in 1981. So that got him the tenure in Princeton. Of course, tenure in Princeton is not easy. So he got that because of that fundamental contribution. And his group had been looking at these mechanisms. So I was very happy to see that I can be inspired by a PI who has done this phenomenal contribution. But it was not easy to work with Chuck. And as I said, the demands were large and my experimental skills were little. So I got hammered every group meeting. But I did not leave. And I think that was some of the things that I feel I should credit myself. But I got a heavy dose of understanding photosynthesis from physical spectroscopy, using the best techniques, magnetic techniques, to look at sort of unpaired spin systems, to look at reaction mechanisms. Okay, so tools of magnetic spectroscopy, but also dynamic tools, time resolved spectroscopy to look at reaction mechanisms, to understand biology of these membrane bound complexes, to going into electron transfer, tunneling versus hopping, these kinds of questions. Photosynthesis, Pawan, if you were to ever want to work in future, many physicists like George Fair had looked into photosynthesis, is a research problem in itself. Yes, it presents the best of physics, chemistry, and biology. You have to be the best to understand that very complex system.
It's undoubtedly one of the outstanding challenges. No doubt about it. Absolutely. Yeah.
Yeah. True. And so that group provided me that incentive to learn optical techniques, to learn time resolved techniques, to sort of understand biochemistry, the protein biochemistry, and then to understand how organisms work. So one of the papers that we published together with Chuck was about evolution of oxygenic photosynthesis. So it also told me at least, that how to think about evolution. And it was a remarkable experience with Chuck. I didn't publish too many papers. I published one single paper, which I really feel I'm proud of, which is to identify one of the intermediates in in assembling that cluster. So Pawan, maybe it's very easy for us to look at plants every time in the sunlight, but what we don't see is every 30 minutes, there is a repair going on in plants. And it's that repair mechanism on the level of the photosynthetic complexes happens in 30 minutes. And while we observe these nice looking plants, but they're doing a lot of work internally to repair themselves every 30 minutes because sunlight destroys them. So all the ideas that we kind of borrow from photosynthesis, about using, how to trap light, how to use electron transfer events to store as fuels, we forget that plants also have a repair mechanism, which artificial systems in the lab don't have. We don't have a programmable repair mechanism in a material. So when we learn to do that, we will be as good as them. So this is a very important thing that we miss as chemists. Biology provides repair schemes. Chemists don't incorporate that yet. They haven't incorporated in very complex systems, even the physicists. So I think this is something that I worked on, and I recognized that self-driven systems or self-repairable systems are the need of the hour for any kind of new classes of materials. So that is what I gained from my PhD, and that's where I thought that this is where I would like to go in future too. Um, but fate has its own things. I applied for many places for my postdoc, and one of the positions that opened up was with Richard Matthews at UC Berkeley Chemistry. And the reason that opened up is because he was building microfluidic setups.
Nice.
Yeah, microfluidic setups to do to monitor reactions, as well as to look at diagnostics for cancer tissues. So what the idea was for Rich was, you use fluorescent markers, and can I look at different classes of fluorescent markers and look at the tissue level which particular tissue is a cancerous tissue. And I want to screen multiple such cancerous tissues in a 96 well plate, in a 128 well plate. I want to do it simultaneously within few minutes. So he was building microfluidic platforms for doing that. And I got interested because I thought this is exciting science, and this I could take that idea that maybe someday I will look at the brain. But this was fantastic. And the reason he called me for an interview was he thought that I can set up some maybe magnetic sensors for such a device. And I gave a postdoctoral talk, and he liked it, his group liked it, and everything went well, except that we had 30 minutes to kill. At around 4 o'clock, everything was done. I was sitting in his office, and he said, "Hey, Jyotishman, do you want to hear what the other part of my group does?" And I said, "Yeah, sure." So he said, "We do laser spectroscopy." I said, "Yes, I would like to hear." He went on the whiteboard and he explained to me reaction dynamics at the simplest way and the most exciting way. And I have never forgotten the way he dropped potential energy surfaces, light matter interaction, coherences, and then stimulated Raman spectroscopy. I cannot tell you, Pawan, that those 30 minutes were one of the most remarkable 30 minutes. Just told me, Rich, at the end of that, I told, can I work on this? Because I thought I would work on the microfluidic side and I would detect some cancerous tissues. That was exciting. No, there's no question that was exciting. But when I heard him explain his passion and the way he explained it, I said reaction mechanisms on the excited state is what I want to do. And he changed the course of my life. In those 30 minutes, he told me, "Oh, you want to look at the setup? We have developed this femtosecond stimulated Raman spectroscopy. It's one of the best setups that can look at time resolved information, Raman information on the excited state. So do you want to look at it?" I said, "Yes." And I went into the lab, and it was mind-boggling optics. I had no idea what these did. And there was colored light coming from all places. There was a white light continuum. There was some tunable green laser that was coming up with femtosecond pulse duration. I was blown away, and I don't know how anybody can resist colors. If somebody shows that kind of an equipment with that much complexity, and generating beautiful tunable colors. I don't know how a biologist can resist working in optics. Okay, this is just was mind blowing to me. So that opened up a completely different uh, research question or a mindset for me. I said I want to do that. Forget magnetic spectroscopy. I want to do that. Forget sensing. Forget microfluidic devices. I really want to do this. So, couple of months later, he offered me, and that
Oh,
was
wow.
yeah.
Well,
And
I had the privilege of listening to Risha Mathe's in I-Course, one of the I-Course. He gave a tutorial talk before the I-Course. I-Course is a very famous the meeting which happens in International Conference on Raman Spectroscopy. And that in one of the meetings which actually was held in Bangalore, there was a very nice tutorial
tutorial
session.
set.
And I sat through his fabulous teaching part of this conference,
Stimulated Raman concept.
stimulated Raman concept, and what a pleasure it was. What a pleasure it was. In
And
fact,
no,
yeah,
no, please continue. Please continue.
yeah. It means you could see that that enthusiasm to do work not only stems from understanding the beautiful aspects of molecular systems, but also in communicating that excitement. In literally that's an excited state chemistry,
Yes.
which Jyotishman actually has taken forward in the legacy of all these fantastic researchers. Fabulous,
No, but
Jyotishman.
Pawan, I wanted to say that the language he spoke,
Hmm.
and I don't know if this connects to you very well. I think it connects. He spoke about the phase space, and he said reaction dynamics currently is only being done in the reaction coordinate space. People forget the phase space, and that is where I think his ideas of looking at dynamics from a perspective of wave packets in a phase space is something that triggered this entire idea how to watch wave packets evolve. So, and wave packets, just for everybody's convenience, wave packets are coherent superposition of states, vibrational states that can exist in a system, molecular system. And when you do a short pulse excitation, you basically create a lot of these wave packets on the excited state, and they become like particle like entities, more localized than your wave functions, the constitutive wave functions, which are vibrational wave functions, but they actually speak to you like a particle. So that was the beauty when Rich described to me on that board. He said, I don't care about what others say, but I care only about the phase space and how the wave packets evolve. Then you can project it back to the chemistry. So let's watch the wave packets. And that's where I think Rich caught my attention. And this was a remarkable thing for me. And my experience with Rich Pawan has been incredible. He did not like my initial enthusiasm in the lab. In 1 month, he told me, "Look, JD, you have to work 24/7." So I was taking the weekends off because of other things. But he said, JD, you have to work 24/7. You haven't worked in a laser lab, so you better buckle up. And he gave me that impetus and push. And he told me that, look, learn this. You have a very good biophysics background. You have learned in proteins. You have worked with photoactive proteins. So why don't you use this technique to look at photoactive systems? And I looked at one of these important signaling proteins called phytochromes, and I worked to get the first FSRS data on phytochromes and published in 2009. And the work that led up to that was a very good collaboration with UC Davis, who supplied the sample, but it also became, because I was from a background in biophysics and biochemistry, I could talk to these people. I visited them so often that I almost became a member of Clark Lagarius's group, who is a National Academy member, looking at phytochromes. So that was another experience for me, that I can jump from one topic to another topic. It was a realization that my broad training in photosynthesis enabled me to look at either one end laser spectroscopy and think about optics, but also sort of, you know, um, exploit my bank on protein biophysics.
Fabulous, fabulous, Jerry. This is such a beautiful overview what you painted for us. It also actually tells that how important this viewpoint of looking at molecules, molecular structures, and you correctly mentioned about the space-based viewpoint. This is so critical, especially what is the spectra at the end of the day? It's essentially actually taking something from one space to another space. And you can see how effective it is. I
Yeah.
don't think any part of science or technology can survive without that viewpoint. Right
Yes.
from, let's say, rockets which are going out to the space, down to your biomedical, your technology, everywhere there is some kind of a spectral signature which is
That's right.
essential. So now give us an overview of your current passion and why did you first of all come back to India? And second of it, what has been your group up to, and what are the questions you have been asking? And then we'll broaden it up and also get some more insight into your other interests.
Yeah. Well, it's already being a bit long, so I'll just
No,
quickly
no, no. Okay.
summarize. My interest was not there to return back to India, to be very honest, Pawan. I thought I would be setting up a lab in the US. Uh, and right around 2008, 2009, when I started doing the applications, there was a recession that hit US. I don't know if you remember this.
Y- Yeah, yeah. In fact, it's very interesting that you're mentioning this because this is since you mentioned about recession, I actually went to US in December 2008. That's when actually the elections got over. Obama was
Yes.
just elected, and there was a recession hitting, and I was actually entering US. And it was a very, very interesting time. But nevertheless, the enthusiasm and also the push for science was quite a lot.
Yes.
In fact, that
Yes.
was
Yes.
outstanding, and I should really appreciate that American system. And I am hoping that it's going to
At
actually
that
sustain
time, at that
at
time,
that.
Pawan, now things are
Yeah,
different. So
yeah, yeah. At that time, but I'm hoping I'm thinking that it's going to still actually
yeah.
hold strong. Yeah, please go ahead. Please go ahead. Yeah.
No, so no, I think that's lovely to hear that in
Okay.
2008 you
Yeah.
were also hitting your stride in the US. Um, we were sort of applying, and I actually I have a spouse, Professor Ankona Datta, who actually was also applying during very similar time
I have to
scale.
mention, Professor Ankuna is an outstanding, chemist who also actually is in Tata Institute of Fundamental Research. It's only a matter of time before she also appears on this particular podcast because that is something I actually, even slightly even before JD, I wanted Ankuna to actually appear on our podcast. It's going to happen. Again, an excellent, research scientist, also a great human being. Although I've interacted less compared to JD, but whatever I've heard and whatever I've actually learned about her, I'm really looking forward to having an interaction at some point of time.
Yeah,
Yeah.
so I didn't want to name drop, but I just wanted to say that at that time, I was applying, and there was a recession, and since it was a two-body problem, we had to apply together, and many of the universities uh, actually had to cancel the original advertisement. They pulled
Mm.
it back, stating that they don't have the funds to give a young PI a startup package. And that kind of bothered us quite a bit. Many, not just us, but many people who were together, applying together for places. And this was also the time that I think India gained. Okay. Not just because I'm saying that I applied or anything, it's just that a bunch of people applied back home. Okay. And this was the time when Abhishek De
Yeah.
and Shomdatta Ghosh, they also applied. We were in touch at that time. And Abhishek is a
Oh, yeah,
fantastic
yeah.
inorganic chemist. So
Abhishek Day is a superstar. In fact, he's an industry superstar. Again, I don't want to actually describe all the things because
sorry.
these are all on my list at some
Yeah,
point in
yeah,
time.
yeah, sure.
Because I have a very close kind of,
Yeah.
love for physical chemistry people.
Yes, yes. No, no, absolutely, absolutely. No, I'm just saying that all these people, we all applied back home. And luckily for us, Pawan, many of us, the doors were open. The reason the doors were suddenly open is the system that you are sitting in right now, called the ISER system, just got born. And 2008 was a watershed kind of for that, the ISER system, because the government thought it's a great idea to invest in an institute which can do both primary, undergraduate education as well as cutting edge research science. And this was only for sciences, not for engineering, because engineering had the framework of IIT. But IITs didn't have the mandate of doing research. But ISERs would grow into such a sort of a diverse institution, just like the best institutes in the US, like Harvard or MIT, or where both undergraduate education and research is given equal priority. So, 2008 to 2010, the ISERs were born and pretty much seeded. And of course, there are lots of people to thank. But what I would suggest, I will say, is Sina Rao had some role in that. Um, but there are other physicists who also played a role.
Yeah.
However, what I would say is it's that time when the mainframe of institutes also were open to taking lots of people who wanted to come back. And I came back to TIFR eventually. TIFR simply was outstanding to me because it gave me that first impetus of research. And I had good experiences, and also the fact that TIFR gave me the seed funding to build a stimulated Raman setup, which played critical role. Pawan, you would know that even you, when you came back and you were to set up these optics, microscopy or even optics setup, you need these seed funding. And if you are in a young ISER, probably that will be there. It's if it is a little bit more established ISER, those are a little bit complicated things. But we were lucky at that time; we were given the money, and I joined here, and I had to distinguish myself from what I did previously. So I was very biophysical oriented at the time. But my sort of initial research idea was to look at photosynthesis. But then I recognized that photosynthesis, to work on photosynthesis, I need a team of different classes of scientists. So I did not continue looking at that problem because I thought it might be more challenging to set up in 5 years, simply because there was a tenure track that TIFR was practicing at that time. And this is a very, very important part of the discussion. I would like to state that tenure track is one of the best things that happened to me. Okay. In many other places in India, there is something called a probation, a 1 year probation, or a 5 to 6 years evaluation. But a tenure track is a process by which you have to be judged internationally for a program that you have set up. And TIFR, given the money that TIFR had given to me, although there was a lot of initial hiccups because of the space, the lab space, as you know, Pawan, TIFR is space constrained. But
Hey,
given the money,
you have the C.
I have the sea, yes, absolutely. And I can dream anything, right? So, no, no, absolutely beautiful sea and the visuals. But it is a little bit of a space constraint problem. But since the money was there, we could dream big. And we set up a stimulated Raman setup. It took us some time because of all the issues with the infrastructure that we have. I had thought it's the same infrastructure I will get in the US in here, but it turns out that I built the rooms, I built the AC conditioning, and it was never up to the mark, which I could get in the US on day one. But anyway, leaving those struggles aside, I could set up a stimulated Raman setup, and we published a paper in 2017. So I joined in 2010. It took me 7 years to publish that paper. It came out in Nature Communications, but it was a very important paper for the organic photovoltaic community. And it took us 7 years to conceive of that experiment, from the framework of building the laser setup to getting the data and evaluating the data, and talking about its reproducibility. So, and publishing, of course, it's a year's worth of effort. So I we set that problem up, but during that time, I made use of my photosynthesis background to generate a new idea which was not in my research program, which is to do confined photocatalysis in nano cages. And this idea came because I was in Chuck's group, and we did something called as proton coupled electron transfer. And this has now seeded my group's primary focus. The paper came out in JAX in 2014, where we reported we can do proton coupled electron transfer in water with visible light. And we can create neutral radicals, highly reactive radicals, and make them stable inside cages. So that seeded a chemistry that is completely new at that time. And we have been following it up in a big way. In fact, every other day, we have a conversation of a new idea on that. So that did not come across with a thought process that I will set that problem up, but it came across because I had a PhD and a postdoc experience, which enabled me to get into excited states from my postdoc and sort of PCET from my PhD. And that combination was a powerful one. And the fact that now we will report the first paper of looking at PCET with fizzers is going to come up soon, is actually after how many 15 years. It's actually a fantastic landmark for us, because we have demonstrated a CH activation reaction using PCET that we can track. CH activation we can track with Raman. So this is something I'm absolutely excited about. And it took us time, but good things do take time, and it's for all young people that chemistry or physics or biology, it's not about papers. It's not about number of papers. Yeah. It's about finding what you want to do and demonstrating that to the world.
Fabulous, fabulous.
Pawan, as I was saying that, this has been a remarkable journey for me. Starting the lab at TIFR and coming up with problems that, again, that came about to us serendipitously, because we were thinking about charge transfer and things which bothered us for a long time, as bothered me for a long time as a scholar in PhD time and postdoc time. But really, this entire idea of doing proton coupled electron transfer in confined space just was, I would say, an organic evolution from the PhD and postdoc. And the fact that now we are monitoring these reactions with Raman, which Rich Matthews talked about, looking at the structural evolution, is so gratifying to me. Because if I had a chance, and we do keep in touch, Rich and I, he always sort of makes a note that he likes the nano cage work. And so it's been quite a bit of a I would say I have benefited from my advisors in more ways than I can thank them for. So and it's been such a big support in my life. The tenure process was done because of their support. The promotions that have happened to me over the period of time. They were because of their support. Also, support from the community who like our independent work, and also all from you in Indian community, because I don't think I've ever been in a conference feeling dejected, or felt that my science is not being heard at, or never felt that somebody is trying to be unfairly critical of my work. Everybody there have been fair criticism, and I have taken them very well, but nobody has been unfair. And that has been one of the great things about this community. Of course, for any young comer, or young faculty member, it becomes difficult to sort of find a pivot, whom to trust, whom not to trust. That is always there. It's a human, it's a human community. I'm not saying that India is devoid of individuals who don't mess you up, but you have to find your sort of groove within the community. And I've been lucky that TIFR seeded me, because Shudipto Maiti was there, as you said, and he included me in the fluorescence community. That made me come to being friends with your supervisor, Chandrabhas Narayan. It was one of the most amazing things of my life that I came in touch with Chandrabhas Narayan, an incredible person who is out to give himself up for the benefit of the community. I don't think, Pawan, you can count maybe handful of such people in the community like Chandrabhas. And I'm so happy that you did your PhD with him. And I would like to hear something about Chandrabhas, because he has been such a big support for me throughout my career. And I don't have enough words apart from Shudipto Chandrabhas.
Yeah. Chandrabhas, I did my PhD with Chandrabhas. Professor Chandrabhas, JNC SR, is an outstanding experimentalist. I worked with him. The skills of optics, using hands with minds. That's where, it's like in wrestling there is a akada, right? You go to Bast lab. That's the training you get in that sense. We've all benefited. Great. It means, again, it's both passion and compassion. That's a combination which I keep telling, because it's so important, and that's actually an important part of doing science. I think that's also very much part of your own research life. And anybody who has peripherally come in the orbit of JD would actually feel that passion and compassion, as you can already see that. So, JD, we are almost coming towards the end.
Yes.
So give us a gist of how some things which you
Future.
actually, future aspect of it, and also your recommendations going beyond science.
No, so first thing I would like to say, first of all, coming back from Chandrabhas, Pawan, you have been a tremendous support for our entire enterprise of FCS, which, as the audience heard, that FCS is this entire National Fluorescence and Raman workshop that was started by Shudipto. And then we joined in. I was told to present something in 2010 on Raman spectroscopy in Nehu. That was the first time Raman was introduced. I gave a lecture for 2 hours on resonance Raman Pawan. And then Chandrabhas joined in 2011. And I think the decision of having Chandrabhas and then you join in was one of the best decisions for our Raman part of the workshop. And I couldn't have asked a better friend, Pawan. Being just like you carry Chandrabhas's signature in you. You are one of the most humble and helpful people. And my recommendation in general would be, if you were to sort of succeed in science, the first thing you have to be is a good human being. And I found those qualities in you and Chandrabhas and many others in Shudipto, and that is a prerequisite, according to me. That's a prerequisite. because you have to give up so much in education sector. You have to be outside. You have to give yourself up. And I think no better examples than I mentioned the names. And my thing would be that I seriously feel convinced that the Indian community needs honest opinion of what the quality of science is being done. And that honesty has to come with some belief and trust that these human beings who are telling me, giving me a critical opinion, have the best in mind. And this is something that the Indian academic sector needs it right now, because we have an influx of brilliant minds. I can tell you that every university and institute in India at the youngest level, not the lowest, the youngest level, have the most brilliant minds.
Brilliant. Yeah.
And I myself am enamored by the young faculty members in our country. And I have made good friendships with organic chemists, inorganic chemists, physical chemists. I look out for those moments when they are explaining the science to me. I tend to listen, and that's, I think, a good quality within me. I tend to listen, and I love the fact that they are so passionate, and we have a bright future. The only thing that we need to do as a mentor group, as us, as our generation, we should be honest. We should be honest in giving them the feedback with the best of my mind. I do not want to put anybody down. Don't put anybody down. Encourage people to do the best science, but be critical, because there are ways in which you can deviate yourself in an exploration, right? And so a critical feedback in science, that means knowing the science that those young people are trying to pursue, you should read about them and give critical feedback. And that is something that is missing, because nobody has the time to sacrifice and give up for someone else's program. And that has to change in India. That has to change. I think you should be able to give your time, at least a bit of it. I'm not asking for 10%. I'm asking for 1% of the time to some young faculty who is trying to build a lab. And if you can give that time and support, that young faculty, I am sure, will do remarkable things. And I think I try to do that within our department, but I also try to do that with other places, other institutes. And I've been enriched by all those interactions. So this is what I feel we as a community can do, and support one faculty who is not in your institute, and just listen out to their problems, listen out to give the time and maybe help others. And this is, if this can be done, I think we are in a good space, Pawan, because the mentor group is good. The current mentor group, our generation, we have got some leaders in the community, and if we want to do even better, that's from the younger generation. We can be, of course, selfish and say, let me focus to the next best problem, the next best challenging question. Of course, put 99% of that effort, but that 1%, keep it for somebody who you think deserves your time and support. And I think that is going to go a long way. Also, the younger faculty or younger person could be a student. Rohit, okay, a prime example. When I think I came in touch with Rohit while he was doing a master's project with you and working on those anthraquinones, if you remember. And I had beautiful conversations what he wanted to do in his PhD. Till after he went to PhD, he informed me of every stage of his career. Whenever I met him, I learned something new that he was doing. And I think that was a fantastic interaction and an engagement that I had that I still carry.
Yeah,
And I thank.
yeah, for people who don't know, Rohit Chikkareddy actually is an outstanding student of IISER
Your group.
Pune,
Yes.
who did a master's in my group, went on to do a PhD at University of Cambridge, and then was also a Trinity Fellow as a postdoc, and then he's a faculty at the University of Birmingham doing
Yes.
fantastic work,
Fantastic
lot
son.
of lot of fabulous things.
And
So,
it came from your mentorship. Came from
well,
your
yeah,
mentorship. And I think, Pawan, you have had you have played an enormously important role for your student Sunny, for example, as
yeah,
well.
yeah, yeah. He's in
And
Oxford. He's in Oxford.
he's in Oxford. He's in
He's in
Oxford.
Marie Curie Fellow. So
Yeah.
the and so many of them. In fact, they are all benefited from the interactions from the community. IISER Pune actually has a very strong role to play in all those things. Of course, see, it's only a facilitation. I don't want to take too much of credit because they have all really worked very hard. All of them. In fact, I have had outstanding PhD students, undergraduates, even the people whom I work every day. As I write in my website, it's actually a learning process for me because you can relate to that because a lot of stuff thinking happens in the laboratory. In fact, we can define a problem, but the nitty-gritties of the problem actually are in really going and trying to figure out what are the specifics of
Exactly.
certain things.
Exactly. Exactly.
Anyway, so Jyotishman, it's been a fabulous conversation, I'm not surprised that we actually had such a long kind of interaction. Tell us how do you relax, JD? In fact, that's something people should know. An excited state chemist, how should actually come back to the ground state? How do you look at life outside science, and what do you do other than that?
Yeah, so I am sorry that I don't have much avenues for relaxation, only few. But one of them is watching sports, and I watched yesterday the women win the World Cup. Every ball I watched. So that is one way of doing relaxation. I play sports. I,
What a
I
match!
used
What a
to.
match! What a
What a
match!
match!
What a
What
match!
a match!
Yeah,
Incredible.
yeah,
The women
absolutely.
showed what the men couldn't do, how it should be done.
Absolutely.
So it was a fantastic match. But yes, that is one aspect to it. But the other aspect is also following up on my students. That's a relaxation. My students, my own PhD students now have become independent faculty. One of them, Palash, you must be knowing,
Yeah,
is in
yeah.
IIT Bhubaneswar. Ajay Jha, who is a PI in RFI in UK. Rahul Gera, who's IIT Jodhpur. So these students keep me engaged of what they are doing, and I like having conversations with them. Of course, they are all senior now. They are all within their own right making decisions and everything, but that is such a good relaxation for me just to talk to them. And I love talking to people within the institute, also learning from the graduate students within the other groups, not just my group. So that is how I relax. I actually kind of am doing a lot of work from the morning to the evening. And I love my office, fortunately. And that's sort of where I am most of the time. But now with my son growing up, who is now in cross 10th, 11, 12, I'm trying to spend some time with him too. And um, absolutely, from day one, he has been a point of relaxation whenever I used to come back to home, looking at his face and talking to him. So he has grown up now. So sad part is when he was a baby, he was amazing. When he's a grown adult, he's still amazing, but he has his own ways of doing things, and I can't force him to be with me. But but that's another. The family itself is another place where relaxation happens. So not much of art and culture. Ankona practices music, so she
Yeah.
has a very deep rooted interest there. But I am of the not very talented type. I tend to appreciate what people do. and I enjoy those moments. But overall, I think science is where my relaxation really
Relaxation.
is. And I feel that I feel uh, uh, that sometimes every person needs another venture.
Venture, yeah. Yeah.
Yeah, and they should do it with passion, similar to their main profession. So I highly recommend not having a lifestyle like me, but exploring your hobbies, and that always takes you away from the pressures of the profession, and also helps you grow more patient
Patient, yeah.
in yourself. So I think that's where, yeah.
Fabulous, fabulous, JD. It's always nice. In fact, as I told, even if it's online or offline, these kind of conversations always, add new kind of life into the already kind of floating body of stuff. And we hope to actually also continue the conversation because there are so many things to discuss. There are people whom I'm surely going to kind of broaden the discussion in terms of how the research problems, what you're working on. I'm very sure we would actually have this conversation again on the podcast at some point of time.
Sure.
So thank you
Sure.
very
I
much.
just I just I just want to say one last thing, that
Yeah.
um, for all young members in academics, I think academics is a way to serve the community. It should not be a way to fulfill your ambitions. So I think if we keep remembering that we are serving
So,
and not taking
mm,
everything for ourselves, that should be motivation enough to continue.
to continue.
And that only will lead to good impact in science. There is one scientific impact, and then there is a human impact. Let's not forget there is also a human impact associated with every academic. And I think that human impact has to be to serve the community. And it cannot be
Absolutely.
more than that.
I see a photograph behind you, and there is no better example of this thinking than Homi Baba. In fact, Homi Jahangir Baba, just very recently was his birth anniversary, which was also commemorated. And even in IISA Pune, we have his memorial lectures, which is coming up on April 7th. So yeah, that's actually, education and also knowledge which is shared, his knowledge doubled, so to speak. And that's the excited state chemistry which is inculcated with passion and compassion of Jyotishman is what actually we wanted to communicate in this episode. Thank you, JD, very much for your time and also for your thoughts. It was an absolutely fabulous chatting with you. Yeah, thank you very
Thank
much.
you, Pawan. Thank you very much.
Oh,
I enjoyed thoroughly. So.
it is Pratidwani, where we try to humanize science, this time with the one and the only Jyotishman Dasgupta. Thank you, Jyotishman. Bye bye.
Bye.